Today we are going to learn about similarities in right angle triangle. Now, we have already learned about similarities in triangle and today we are going to continue from there. Now let's say there is a right angle triangle ABC. So this is vertex A, this is B and this is C and this is right angled at B. Now let's draw an altitude to the hypotenuse which is AD. Now if I say that this angle A is theta, can we say angle C will be alpha where theta plus alpha is equal to 90 degree. And then in triangle BDC, can we say that this angle will also be theta, and in triangle ADB this angle will be alpha because theta plus alpha is 90 degree. Now in triangle, can we say triangle A, B and C will be similar to triangle. So ABC will be similar to triangle A. Instead of B, D is 90 degree and then B. We can say triangle ABC is similar to triangle ADB. So the relation that we get here is between the side lengths, it will be AB upon AD is equal to AC upon AB, which is equal to AB upon AD. So now taking these two together, can we say that AB square will be equal to AC into AD. Now this is a really good result. You should remember this, that AB square is equal to AC into AD. Okay. Now in triangle ABC and triangle BDC, can we say angle A is theta, here angle B is theta. So triangle B and angle B is 90 degree here angle D is 90 degree. So it will be triangle BDC. Now from there, can we say that AB upon BD will be equal to AC upon BC, which will be equal to BC upon DC. So can we say that BC square will be equal to AC into CD or DC, whatever you say, right? Both of them are same thing. So another result that we got from here. Okay. Now apart from this, there is one more result that we can look here, that triangle ADB will be similar to triangle BDC. D is 90 degree, A is theta, in this case angle B is theta. So we can say now that AD upon BD will be equal to BD upon DC, which will be equal to AB upon BC, right? So from here you can see, can we say that BD square will be equal to AD into DC. So this is the most important result of all these three results. Okay, BD square is equal to AD into DC. BD square is equal to AD into DC. So this is the similarity concept in right angle triangle. Now let's move on to the questions. First question, it says in triangle ABC, right angled at B, BD is perpendicular to AC. So let's draw triangle ABC. Triangle ABC, right angled at B. BD is perpendicular to AC. BD is perpendicular to AC. Find the length of BD if length of AD and CD are, AD is given 9 centimeter, CD is 12 centimeter. So what do we know? We have just learned in the previous slide that BD square is AD into DC. So we can say that BD square is equal to AD into DC, or we can say BD square is equal to 9 into 12, or is it 12? Yes, BD square is equal to 9 into 12, or BD will be equal to square root of 108 centimeter, right? Or BD can be written as 6 root 3 centimeter. That is our answer. BD is equal to nothing but 6 root 3. 9 into 12 is 108. 108 is 36 into 3. Square root of 36 is nothing but 6. So 6 root 3. Now, what's next? Next question is an amazing question based on similarities. It says in a right angle triangle, ABC is right angled at B. This is a right angle. And ED is parallel to AB. These two are parallel. These two are parallel means ED is perpendicular to BC. If the area of the triangle EDC is 12 root 3, then find the area of the triangle ABC. Now we know that triangle ABC and triangle EDC, both of them will be similar to each other. Triangle ABC will be similar to triangle EDC. Why? Because both of them, angle B is 90 degree, angle D is 90 degree, angle C is common in both the triangles. So by A rule, both of these triangles are similar. Now let's see, if this is 45 degree, can we say this will also be 45 degree? And if this angle is 30 degree, angle C will be 60 degree, this angle will be 30 degree. Now in any 30, 60, 90 triangle, what do we know? 30, 60 and 90 triangle, the ratio of sides opposite to 30 degree is 1, then opposite to 60 degree is root 3, then opposite to 90 degree it's nothing but 2. So this is 2. Now can I take the side length opposite to 30 degree as 1, then opposite to 60 degree ED will be root 3. And in that case, if ED is root 3, can we say BD will also be root 3? Right? So in this case, what do we get the ratio of corresponding side length? Opposite to 30 degree, it's BC, and opposite to 30 degree, here it's DC. So we can say that BC upon DC is equal to, BC is root 3 plus 1 and DC is 1. So what will be the area of triangle ABC divided by area of triangle EDC? Now we have learned in similarities video, similar triangles video that the ratio of area of two similar triangle is square of ratio of their corresponding side lengths, which is root 3 by 1, root 3 plus 1 upon 1. So this will be root 3 plus 1 upon 1 whole square. So from there we can say area of triangle ABC is equal to, this will go right hand side, this will become 3 plus 1 4 plus 2 root 3 divided by 1 into 12 root 3, which gives us 12 into 4 48 root 3 plus 12 into 2 24 into 3 72. So this will be 48 root 3 plus 72 centimeter square. So our answer is option B. All right. Now next question, it says find the ratio of AD is to DC. In this case AD is to DC we need to find. Now we have learned in similarities in right angle triangle that AD upon BD is equal to BD upon DC is equal to AB upon BC. So AD upon BD, AD upon BD is equal to BD upon DC is equal to AB upon BC. So can we say that if I multiply AD upon BD into BD upon DC, I can write it as AB upon BC into AB upon BC. This is equal to this and this is also equal to this. So from there, BD cancelled out. We can say AD upon DC will be equal to AB square upon BC square. And what is AB? AB is 6. So 6 square upon 8 square. This is 36 upon 64. If we divide this by 4, we get 9 upon 16. So option B is our answer. So as I said, similar triangles के जो concept है उन्हें use करके similarities in right angle triangle we get lots of different concepts that you can use to solve these type of questions very quickly. So let's go to the next question. Find the in radius of the triangle ADC of triangle BDC to in radius of triangle BDC if BD is perpendicular on BC. So we already know that triangle ABD will be similar to, so if this is theta, then this will be alpha and this will also be theta and this will be alpha. So ABD, instead of A we can write B here, then D here and then C here. Triangle ABD will be similar to triangle BDC. Now can we say that against 90 degree AB is 8 centimeter, against 90 degree BC is 15 centimeter. So what we can say that AB upon BC are corresponding sides of this similar triangle which is equal to 8 by 15. And we have discussed during similar triangles that the ratio of corresponding sides between two triangles is same as the ratio of any linear length of those triangles. For example, the ratio of perimeter of these two triangles will be 8 by 15. The ratio of medians drawn to AB to medians drawn to BC will be 8 by 5. The ratio of circumradius of triangle ADB upon BDC will be 8 by 5. And similarly, the ratio of in radius of triangle AB ABD divided by ratio of in radius of triangle BDC. This will also be same, which is 8 upon 15. No need to calculate anything here. This is a direct approach. The ratio of circumcenter will also be same. The ratio of altitudes. Let's say there was a question something like that this is P and this is Q. So what will be the ratio of PD upon DQ? So again this will be same as 8 by 15. Okay, or ratio of any altitudes. Okay, corresponding altitudes. यहाँ A से परपेंडिकुलर ड्रॉ करें, ऑलरेडी परपेंडिकुलर है, कुछ और ले लेते हैं. लेट से A से हमने एंगल बाइसेक्टर ड्रॉ किया और हमने यहाँ B से एंगल बाइसेक्टर ड्रॉ किया. रेशियो ऑफ देयर दोज विल बी सेम. So I hope you understood this part. Okay, now next question, it says given right angle triangle ABC, AD is equal to DB. AD is equal to DB. These two are equal. D is perpendicular to AB. AB is equal to 10. If AB is equal to 10, then we say AD will be 5 and this will also be 5. AC is equal to 6. AC is 6. This is 10. This is 90 degree. This is 6. Can we say using Pythagoras theorem 6, 8, 10 Pythagoras triplet BC will be equal to 8. Now find the area of quadrilateral ADEC. ADEC. We need to find the area of this quadrilateral. Now check this. If this angle is theta and this angle is alpha, theta plus alpha is 90 degree. Can we say this angle will also be alpha? So can we say that triangle ABC will be similar to triangle angle A is alpha, angle E is alpha, C is 90 degree, D is 90 degree. So this triangle ABC is similar to triangle EBD, right? So in that case, what we can say, that the ratio of corresponding sides, what will be the ratio of corresponding sides? So against alpha it's 5, so BD upon, against alpha here it's BC, so BD upon BC is equal to 5 upon 8. So the ratio of corresponding sides of these two similar triangles is 5 by 8. Can we say that area of triangle EBD divided by area of triangle ABC will be equal to square of the ratio of corresponding sides, which is equal to 25 upon 64. Now think about this. If I take the area of this triangle as 25x, area of this quadrilateral should be 39x, right? Then only 25 plus 39 is 64x. So we can say, what will be the area of triangle ABC? Can we say area of triangle ABC is equal to nothing but half into 6 into 8, which is equal to 24 centimeter square, and this is nothing but 64x. So can we find area of quadrilateral ADEC, which is equal to nothing but 39x, or instead of x I can put 39 into, say x will be equal to 24 by 64, so put it here. So 8 into 3, 8 into 8, we get 117 upon 8 centimeter square. So this will be equal to 1837, 4 times 50, 6 times 20, then 2 times and then 5. So 14.625 centimeter square. है ना? So again, one more breathtaking question on similarities in right angle triangle. I hope you understood the solution. So with that, we are done with this session and we are done with similar triangles for now. So we are going to choose some new sub-module of geometry in the next video. So I hope you are enjoying these sessions. Thank you.